Hello everyone, and welcome. My name is Zach Pleasant, and I'll be helping with facilitating today's webinar. Today's webinar is titled, Best Practices in Evaluating Performance Data for Transportation Systems, Management, and Operations Strategies, and is sponsored by Federal Highway Administration and hosted by the National Operations Center of Excellence, or NOCO. As a quick reminder, if you don't know already, at NOCO, we offer a variety of resources to support the transportation systems management and operations community. On the right side of your screen, you can see a box called Useful Links. You can browse through those links for TSMO resources and news. Now I'll cover a few logistics for today's webinar. We are recording this webinar, and the recording, along with the presentation slides, will be available through the on-demand learning section of our website. All the attendees' phones are on listen-only mode by default, but we'd like you to stay engaged by using the question discussion pod for comments and questions. We have a question and answer session at the end of the webinar, so if you have any questions, we encourage all of you to enter them in the questions pod as they come to your mind throughout the webinar. The questions will be read out loud one at a time by the moderator, and our presenters will answer each question. That's all I have, and with that, I'll hand it over to our moderator, Daniel Great, to start us off.
All right, thanks, Zach. First off, I want to introduce myself. My name is Daniel Great, Jr. I'm with the Federal Highway Administration's Resource Center out of Atlanta, and I am on the Operations Technical Service team. And I would like to welcome you today to today's session that's focused, again, as Zach mentioned, on best practices as it pertains to evaluating performance data for TSMO strategies. Just to give you some background in terms of motivation as to what got us here, many of you may remember a few years ago when we had the Sharp 2 effort underway. Federal Highway conducted some 40 to 50 workshops, which were self-assessments in terms of operations. And we took a look at where state DOTs and MPOs were in terms of their operations program. We used a tool called the Capability and Maturity Model, and in that tool there were 6 dimensions. Performance measures and management was one of them, and it was heavily focused on data. How are folks collecting data, who owns it, and ultimately how are they using it? One of the things we found out during that part of the workshops is that the agencies were what we call data rich. However, there wasn't any formal practice or tools in place that they were using in order to analyze big data to help with decision making. Since then, there have been a handful of tools and best practices that have surfaced, and a couple of those best practices we're going to be covering today. We have 2 agencies or 2 tools that we'll be looking at today. The first one is from ARC, Atlanta Regional Commission, which they have a tool entitled DASH. And then the next one will be from Texas, the El Paso region, where the the Texas MPO has partnered with the University of Texas at El Paso to develop a web-based tool also that can accommodate big data for TSMO strategies. With that, I'm going to go ahead and introduce the first speaker. We have Kwang-Ha Kim. He is the Performance Analyst and Managing Manager at ARC, the Atlanta Regional Commission, and she and her team will walk us through the DASH tool. With that, I'm going to hand it over to Kwang-Ha Kim. You have the floor.
Hello, everyone. My name is Kwang-Ha Kim, and I'm the manager for the performance analysis and the monitoring team at ARC. First of all, I hope you all safe and healthy at this difficult time. Yes, I'm at home and I'm doing this. Today, we would like to present our experience with data and tools and an example how we've done TSMO TIP project evaluation process. At the end, we want to show you how we communicate all this information with others. So I will cover data and the tools in general sense, and Tejas will talk about our TSMO prioritization method, and Shichen will talk about Dash, which is our visualization tool. So why do we always talk about data and tools? Of course, we love data, right? Because transportation is very complicated, as you know. We try to understand literally everything from economic, demographic, social psychology, infrastructure, and the people's decision on travel mode, route, and time budget, and the many others related issues. Also, transportation planning is not only focused on the current events, but is mostly focused on our future. So we use data to project short-term 5 years models to long-term 30 years models. And we do this through a program called Transportation Improvement Program and the Long Range Transportation Plan. Therefore, transportation data and analysis are the backbone to the plans. And I don't have to even explain why it is so important, because I think you totally understand this. Well, maybe since you are operation data people may not understand this regional need of a big picture. We are talking about quite a big different scales here. But however, these analyses can be from the regional system performance to project level performance and the program performances too. This means transportation truly covers everything. As a planner, modeler, or analyst, or maybe engineers, we always say we don't have enough data. Yes, that may be true, but it is only half true. In fact, we may have too much data, yet we do not effectively using them. We may often lose ourselves in the lake of information. We may not be that skillful how to use it well, even with existing data, to transform the information that can help us to be knowledgeable and wise. Because the numbers hold many stories and the different types of truths too. How we interpret the data makes a big difference to the story. So the problem then is not that we don't have enough data, but maybe rather that we don't have the right data. As we all agree, transportation issues are very complicated. Our goal is how we pick the best project to solve our transportation issues by understanding the need and performance. We are talking about these different types of projects, from multi-million and billion-dollar interchange highway to a project, small sidewalk project can help safety of the pedestrian. How can we compare their advantage and the disadvantage to match what we like to achieve and connect our goals and vision? So at the end, what we want to say is, yes, we picked the best project, and the results are such as. I always feel like I have a disorganized bucket full of information in front of me. What should I do? To do it right, first, we must organize them. But data is not that simple to organize easily. We are talking about various reasons the data can be useful or not useful. In other words, misleading. We must use data very carefully and fully understand what it tells us. Also, raw data itself may not be understandable, so we develop tools to use those data. To do this, we really have to know what we're doing and how we can organize ourselves. I would like to make sure there's 3 important statements. we must understand the different performance by project types and project scale. We also have to matchmake the right data with the right tool and organize data, tools, performance with plan goals. So often, I think data and tools are just like my cooking ingredients and the recipe. These days, I cook a lot because I don't go outside for dinner or lunch. There's a basic similar ingredients, and the taste can be quite different. Just like a very spicy Korean hamburjjigae and Italian cioppino use a similar ingredient, yet the taste is totally different. Likewise, we use lots of similar data from same source, yet our understanding and a conclusion can be quite different. This needs our common sense and how we make a story. This is, I call it, science meets art. So here's the list of our example data and tools. ARC developing all the time these tools and using it constantly. We are updating and modifying these things. We have to understand why we need the data and the purpose of tools to match what our goals are. We should not have the data just because we want it or it looks glamorous. So it must have a clear goal and purpose. ARC's vision and goals are matching with the federal's direction and the state plan. Our performances are also connected to regional, state, and the federal's performance categories. The plan has to be consistent with the supportive data and the performances. Finally, once we have data, tools, and organize the performances to support our goals and plan programs, we really need to have good dashboard to share our information. This is truly bridging between analysts, planner, decision makers, public, literally everyone. Key ingredient is the dashboard has to have a good-looking interface. It has to be attractive, and it has to have common sense data and the robust quality of performance measures that connect to our region's goals and vision. Next to ARC's presenters will cover more details on how we developed and use our TSMO project evaluation method as part of a TIP project analysis, and how we developed and use our dash visualization tool connecting information to our user. Thank you.
What? Well, it's through their internet, but it called me, or I had to call that. Okay, Teja, you're up. So it's just a web thing. Mm-hmm. So normally I could connect to here, but for some reason it's not always working well. So I have their software call this phone.
You have been muted. Your microphone has been turned on.
Okay, we're not able to hear you, Teja, so unmuted you. No, we can't hear you. Do we want to go to Sishin while we figure this out?
I think that's a good idea.
Okay.
Okay. Hi everyone, this is Shichen. My name is Shichen Fan, and I'm a planner at Transportation Group of Atlanta Regional Commission. So next I will introduce ARC's dashboard site for visualizing performance measures and project evaluations. So firstly, let's walk through this site. Currently on screen is the main page of our dash site. The website address is under the screenshot. As the navigation bar on the top of the page shows, we classify the topics and metrics into 3 categories: regional performance, program performance, and project performance. Under the regional performance, now we have congestion management, equity, environment, and transit pages. The safety and infrastructure condition page will be published soon. Other topics and program performance is still under developing. The project performance are mainly project evaluating for RTP long-term plan and team, the short-term plan. These 2 pages share a similar template. And following our today's topics, today we will continue to focus on the TIP evaluation page and the TSMO project. So the current screen shows the 2017 TIP evaluation of ARC. The page composed by 2 parts. On the left, there is an interactive map showing the location of each project. And the color currently stands for project cost, but it's able to switch for showing other index. On the right, there is a scatter plots and 4 selection box. A user can set the X, Y axis, the color, and the circle size for the scatter plots to explore the evaluation data. And under this, there is an option to filter by project type that will highlight selected projects in the scatter plots. Like the page currently showing road operation project, the selected GWITS1 is one of our TSMO projects. We can see its detailed information on the scatter plots. Click one of the selection box. Okay. After click one of the selection box, we could see all the options. It contains 11 specific index. Tejas will later introduce, which we evaluating our project, and the final score we generate from these indexes, and the performance tier and the cost of each project. Click one project on the map or the scatter plots, we can view the detailed information of this project. We continue to use GWITS1 as an example. The left part is a table showing the value of each index. The right part, a bar plot, is used to compare the each index of.
Okay.
Hello? Comparing each index of the project to regional average and project type average. And below it's a data table used to compare cost, final score between this project and the Atlanta regional average. So next, let's have a look at the tools we use to build the dashboard. first part is the web browser languages, the HTML, CSS, and JavaScript. But one problem is that staff in our group don't really have advanced front-end or web development skill.
Is it over?
Excuse me?
I'm sorry. Continue.
Okay. So in developing this dashboard, we heavily rely on R and the Shining package. R is a program language for statistical computing that is more and more widely used in data analysis these days. It's free, open source, and have plenty of resources, so it's very friendly for no matter new user or experienced users to start or learn new functions. And Shining is our package, easy to build the interactive web apps straight from R, so that we are able to skip to learn the detailed JavaScript things. And there is already a ton of resources available, like the link here. It's a Shining's gallery page. People share their visualization projects, and their codes are open to public on this site, which is very helpful for us to learn from when we build our dashboards. And following is some packages to improve the visualization, which we used. First is the leaflets, which used to build the interactive maps, and pie charts and plotly are used to build interactive charts and plots. Their websites have a very detailed tutorial guiding how to create different types of attractive charts. And the fourth one, the data tables, it is to build interactive tables, which allow users to do the filter, sort the data like we can do in Excel. All these packages are originally written in JavaScript, but fortunately now they are already able to call in R and can be used in an easy way that not requires any JavaScript knowledge. Then let's move to how we assemble all these parts, topics together and make it as a data hub. So as the current page shows, we hold a dash at our GitHub accounts. We can see each topic here saved as independent HTML file. We link them together by an index file written in simple HTML script, which serves as a navigation bar, like the top left picture shows the red parts. And then we leave all the complex visualization parts to do in R and Shining package, and use the iframe tag to attach them under the navigation bar. Like the other three pictures showing the red part in our equity, congestion management, and RTP evaluation pages. All the heavy work all did by R in a relatively easy process. So that's all our process to build the visualization parts. Hope it's helpful for you to develop your own dashboard. Next, let's turn to Tejas to talk about how we calculate the index for each project and generate the final score for each project. Thank you.
Hi, everyone. Thank you for being patient. I hope that you can hear me now. So I am Tejas Kotak, a transportation planner with the ARC, and I will be talking about the data-driven processes we use to evaluate TSMO projects that are submitted for Transportation Improvement Program funding, and how that data then goes over to Shichen to create into that data visualization dashboard. So first I want to talk about the history and growth of our evaluation process and how we got to where we are right now. So for decades, we did have a process to rank and score our projects and figure out how to compare them against each other. But for TSMO projects in particular, it was fairly qualitative. It was based more on the broad goals of the project and on the assessment by professional staff just from the project description. In 2017, we overhauled our TIP evaluation process to become far more quantitative, and we especially focused on how to make our TSMO program a lot more quantitative and data-driven. So this slide seems not to have populated for some reason, at least on my screen. But to briefly cover what it discusses, in 2016, we created our TIP Prioritization Task Force. And that task force was a group of ARC staff and other stakeholders in the region to help advise us on what the best practices and best data sources that we need to consider when evaluating these types of projects, including TSMO, transit, roadway expansion, asset management, and other projects that help improve air quality within our region. All of this resulted in a book that we colloquially call the cookbook. We call it the cookbook because it helps give us guidance and direction on how to evaluate these projects, but it still allows us, like in cooking, some amount of flexibility in how we ultimately weight things and whether or not certain parts of the evaluation are necessary for individual projects. So now it's populated. Part of the cookbook framework is what we call the key decision point framework, and that is a multi-step process. The first one is our universal TIP project call, which is where our stakeholders, our local governments from around the region, submit projects to us for funding. The KDP1 policy filter is simply an administrative step to make sure that they've given us all the information that we require and that the projects broadly adhere to regional goals. The KDP2 project evaluation step is what we will go into more in-depth about in a moment. Once KDP2 is done, our projects have been ranked and scored, and then senior staff sit down and figure out which projects we want to fund from using that information and from which funding source we want to fund those. All of our projects require a lot of different variables and a lot of different data sources, and this is an overview of what each different project type considers while we are evaluating and calculating their final score. We just wanted to put this up to show that we consider a variety of different data types and data sources, and that we consider them for a multitude of different project types. Considering specifically what we use for our TSMO scores, I like to put things into three broad buckets. One is the models and tools bucket, and these are scores that we ultimately get from some kind of transportation model or some kind of calculator. And we're able to take the ultimate numbers from these and score and rank them against each other per project. The Boolean bucket, this is something that a project either gets a 0 or 100 for this variable, because a project either is or is not within this category. For instance, for freight movement, a project either is or is not on a freight corridor. It's hard to have a gray area or a tiering for that. The third bucket is what I call the qualitative bucket, and this considers safety, environmental, and multimodality improvements to a project. project sponsors submit to us a written description or a written list of what the improvements they are considering are going to be. Professional staff sit down and figure out how we want to score these, and we do quantify it in the end, but the process to get to that quantification is still more qualitative and talking through with professional staff. And this is something we're hoping to make more numbers driven in the future. All of these variables are ultimately put together into a final score on a 0 to 100 scale, and our projects are ranked against each other. This chart shows how these scores turned out for us in this most recent tip solicitation that we are currently wrapping up. So we have high, medium, and low tier projects based on what their final score was, as well as their cost effectiveness. The cost effectiveness is a comparison of what the actual cost of the project will be, as well as their potential to change vehicle hours of delay on their corridor. This is something that our senior staff takes when we are considering which projects to fund, and it gives them a lot of insight into how effective and efficient it would be to spend federal and local money on these individual projects. And it gives us an easy thing to point to when someone in a local government or within our own team wonders why we did or did not fund a project, because this very clearly lays out how well a project did within our framework. As we move forward, there are a few things that we want to consider to continue to improve our process in evaluating TSMO projects. One of them is that TSMO projects come in a variety of forms. We have more traditional TSMO projects that consider changes in roadway design, such as adding a turn lane or building a roundabout. We also have more technology-focused TSMO projects, such as signal synchronization or anything to do with connected and autonomous vehicles. Should we consider all of these within the same group or find more unique ways to separate them out? Similarly, we still want to consider what are the best performance measures that we want to take into account when evaluating TSMO projects, and what is the best way to compare, contrast, and measure these performance values. So these are some things that we are going to be considering as we move forward with this. And with that, I am done, and we are open for any questions.
Actually, can you guys hear me? This is Daniel.
Yes.
We're going to hold questions until the end, until after Texas has had an opportunity to present. All right. So thank you, ARC. We're going to move on to Texas to have them provide a presentation on their web-based tool. We have Sonia Perez. She is the Regional Transportation Planner at the MPO in El Paso, Texas. And she and a team from the University of Texas, El Paso, will be giving us a walkthrough of their web-based tool, performance-based tool for that region. With that, I'm going to go ahead and hand it over to Sonia Perez.
Thank you, Daniel. Good afternoon, everybody. I hope you can hear me well. As Daniel mentioned, I'm a transportation planner for the El Paso Metropolitan Transportation Planning Organization. And this presentation is a collaboration between the El Paso MPO and the University of Texas at El Paso as part of a contract agreement that we have with the university. This is the outline that we're going to follow for this presentation. I'm going to start with the introduction. I'm going to go over the context and background, the motivation for this tool, and and the approach that was followed. And then the UTEP team will go over the rest of the presentation. They will show the performance measures, data sources, the data analysis. We'll take you into the 2 modules, next steps, and lessons learned. First, I want to provide to you some context and background. So the El Paso MPO is located far west in the state of Texas, and south of New Mexico State. The MPO study area includes the entire county of El Paso and portions of New Mexico, including the city of Sunland Park, Santa Teresa, and Chaparral. We are a bi-state MPO, and also we are a binational MPO due to the close vicinity to Ciudad Juarez, Mexico. The population in Ciudad Juarez is over 1 million, which contributes to the almost 13 million of passengers traveling northbound at the port of entry in an annual basis. Travel statistics from 2017 show that the majority of the trips in our study area are done by car. We have over 90% done by drive mode, and the remaining 10% is divided between walk, transit, bike, and other modes. These statistics are especially important in our study area since we are in a non-attainment area for carbon monoxide, PM10, particulate matter 10, and just recently, the city of Sunland Park, New Mexico has been classified as non-attainment for ozone. In regards to safety, the statistics of 2018 show there were 91 fatalities in the county of El Paso in that year, and from which there are 41% pedestrian fatalities. The MPO has adopted the state's targets, New Mexico and Texas targets, and also the Texas Department of Transportation has adopted a vision of zero traffic fatalities by 2050. This means more emphasis in project prioritization, more emphasis on safety in the project prioritization and design, as well as continuing the education programs and implementation of the safety plan. These are just a few statistics that we can generate from the web tool. Now going over the motivation for the development of this tool. Really the motivation was to be able to visualize the performance of transportation networks so that decision makers and local partners can view the performance measures based on information, available data from various sources, and to track transportation performance over time. This tool will aid the MPO as part of the monitoring elements of the planning and programming process, and this is also part of the congestion management process. A tool will be used for this, the analysis required for the congestion management process. In more detail, this tool was developed based on these 4 goals: to track transportation performance over time, to support identification of gaps in infrastructure across transportation modes, to inform planning and programming decisions, to be a resource for local planning partners and the general public. We want to be able, or we try to be able to answer these type of questions using our tool. Is payment condition improving? Are travel times getting longer or shorter? Has transit ridership been increasing? Have all planned bikeways been built? Is air quality improving? Have fatal crashes decreased? This is how the multimodal web tool looks like. It was developed in a platform to be used in a computer as well as on the cell phone. You have several modules on your left side, and you will go over them one by one next in the presentation. So to finalize the introduction, as I mentioned, this effort is a collaboration between the El Paso MPO and the University of Texas at El Paso. The project initiated in September of 2018 and was completed early this year. We're in the process of having it approved or presented to our board so that we can have it available for everybody on our webpage. Right now, we still don't have it available. This effort builds upon previous projects and also in collaboration with UTEP. In 2017, the completion of a review of multimodal performance measures, kind of like a peer exchange. And in 2018, the completion of a pilot web application of one of the corridors in the El Paso County. The UTEP research team includes graduate students and undergraduate students from civil engineering, computer science, and it's guided by staff researchers. And the MPO oversees the development of the project or oversaw the development of this project and provided feedback. So now I'm going to hand it over to Marqueta Babrova. She will continue with the presentation. She is a postdoctoral researcher at the UTEP at the University of Texas at El Paso. Dr. Babrova has been involved in projects conducted from El Paso MPO since 2016, among other projects. Marqueta, go ahead.
Thank you, Sonia. So in the second part of this presentation, we would like to walk you through the steps that we took during the development of the Web tool. And we believe that this information could be particularly interesting for agencies that are similar situation as we are, which is we are an agency serving small or medium-sized community with limited financial and staff resources. So we approached the Web tool in these 5 steps. First, we focused on the performance measures. Then we gathered and analyzed data. Third, we identified corridors. And ultimately, we visualized everything in the Web tool. So when we were identifying the performance measures, we knew that we wanted to focus on performance across modes. So in this case, we looked into driving, transit, freight, walking, and biking. So when we were looking for the performance measures, we looked into 3 major documents. One of them was the Metropolitan Transportation Plan, then the Congestion Management Process, and also the National Performance Measures. So that's from the MPO documents, we identified 44 performance measures from the existing plans, and then from the National Performance Measures, there were another 21 performance measures identified. So next, we looked into the data availability and suitability for regional and corridor level assessment. So eventually we ended up with 26 performance measures. Some of them were slightly modified from their original, especially those that were identified from the national performance measures, and then we added some performance measures based on peer practices. So there were 6 categories that we divided the performance measures into. So it was safety, accessibility, infrastructure condition, environment, reliability, and mode share. And these performance measures in the Web tool are aligned with the top 4 priorities that the El Paso community expressed during listening sessions for the MTP development in spring 2018, which were to improve safety, improve quality of life, protect environment, and reduce congestion. So here is an overview of the 26 performance measures, and then the 6 categories: mode share, accessibility, environment, safety, reliability, and infrastructure condition. And then the modes that each performance measure is related to. So here we have driving, freight, transit, walking, and biking. So for example, in the infrastructure condition, we focus on pavement and bridge condition. And then we report the pavement and bridge condition in the overall network, then on the freight network, and then on the transit network. So the data sources that we used included both national, state, and local level data sets. On the national level, we leverage data sets such as the National Performance Management Research Dataset, U.S. Census, and the Highway Performance Monitoring System. That's how we were able to get travel times, mode splits, and pavement condition. On the state level, we looked for data available from Texas and New Mexico Departments of Transportation, as well as state environmental agencies. So this data included crash data, emissions, Strava walking and biking trips, ITS infrastructure, and bridge condition. On the local level, we were able to obtain ridership and bus stop locations from transit providers, presence of sidewalks, bikeways, and the northbound crossings and wait times at the international ports of entry were obtained from municipalities. Then planned and existing trails were provided by municipalities and local health foundation, and MPO provided any projects that enhance safety, as well as the congestion management process network. In the data analysis process, our student research assistants who are majoring in civil engineering played a very important role. So in general, the data analysis process fit into one of these two main categories. Some data we were able to visualize in the web tool as it was received. So this included, for example, pavement and bridge condition, crashes, emissions. And then some data we had to first process in GIS software to get, for example, the number of crashes that occurred on the CMP network, or the number of people who reside within a certain distance from a transit stop. So next we will have Sebastian Gonzalez, who is our graduate research assistant, and he was the lead developer on this multimodal web tool to walk us through the functionalities.
Hi, let me know if you can hear me.
Yes.
All right. So thank you, Marqueta. Yes, I'm gonna go over the web tool, basically the major components that it has, and we're gonna go over each of them. So to start with, we have our main menu, which it currently has 6 major modules. We have a module for the regional performance overview, a module for benchmarking. We have another one to see the location of projects that are planned in the long-range metropolitan plan. We also have a module for the regional data repository. Also, an overview of the existing studies in the region. And we also included a tutorial, which is it's just some short videos for users to see and learn, and pretty easy to follow. Okay, so now we have the multimodal performance overview. This is where all of the performance measures are located at. They are categorized under the 5 modes of transportation, which are driving, ride, transit, walking, biking. And this area is just a collapsible menu which expands as you click on each of the modes. Whenever you click on one of them, it will show you the corresponding performance measures as blue tiles, as you can see on the right side. And they include a time period for which the data corresponds to. And then if you click on them, it will display information in the map behind it. And so this is what will look like if you were to click on one of the performance measures. So basically, we display the information on the map, and then we show like a scorecard on the right side, kind of floating above the map. It basically has some graphs on the top. It has the title of the performance measure. Also, it has a section for a summary of what the performance measure is. We have the analysis period. We have our data sources and a short description about how the performance measure was calculated. We also include a small legend in the bottom right. So this tool allows you to interact with most of the performance measures, in the sense that you can actually select to see all the regional data, so that it includes all the MPO region, or you can select specific corridors that we have in our database. And actually, you can also draw your own polygon in the map, and it will display information within that polygon, within that shape, and it will match the results with our database, and it will display the information in the graphs and the summary. So all of that will update automatically as you change with the corridors, or as you draw different shapes. So everything it is dynamic. So the next module that I want to talk about is the benchmarking module. In here, you have the ability to compare regional performance versus any of the corridors, basically. And you can select, I think, up to three different corridors, and you can see their different categories, which are the modes of transportation, and you can see just the side-by-side comparison. You can see the numbers, and you can select, like I said, up to 3 of them. The next module is the MTP projects overview. So in here, we have the projects that are planned in the Long Range Metropolitan Transportation Plan. And this is a table with basic information about each project. And you have the ability to search, the ability to locate. And also, once you locate a project, I will show a pop-up window in the map. So it will take you to the project itself, and it will show you the little pop-up window. And it will include a brief description of what the project is about. And of course, the title. And everything is still here. So every project will be displayed on the map, and you can easily locate each project with the table in the bottom side of the screen. So now we go over to the existing studies overview, and this is a table in which shows all the corridors that we have in our database and how they match with the existing studies that we have in the region. So if any of the corridors are part of that current study, it will be marked with a check mark. And actually, you can click on the project itself, and it will take you it's a link, so it will take you to the page for more information. Like I mentioned before in the introduction, we have a tutorial section, and it's just some short videos for users to see and to learn how to go through the modules and how to interact with the data and see how the area of interest works, because that was quite difficult to implement on my side, but it's easy to use now, and so we have the tutorials for everyone to see. So now I'm going to talk about what the web tool uses, and this is a combination of several tools. I want to start talking about the Google Maps. So everything is laid out on Google Maps, and we use a special key that we have at UTEP to use Google Maps and use their library to help us display information. On the left side, we have Bootstrap that helps us with the layout of the website. It's mainly the design part and the transitions from each module to each module, the menus, how they look, how they react when you click them. And this is just a combination of HTML, CSS, and JavaScript, which is in the middle. And then to handle the data and communicate with the database, we use JavaScript, we use PHP and SQL, and we also combined it with a structure called Laravel, which is it's the database PHP structure that helps us organize the project so that it doesn't get all messy with all the files that we had to work with. And so this is pretty much the tools that we use. We also use some different tools for the charts and some others for other different modules, but these are the main ones that comprise the tool. And so now I'm going to switch over to Marqueta. So thank you for your time.
Thank you, Sebastian. So to wrap up our presentation, so our next steps in the short term include launching this tool hopefully later this month. So as Sonia mentioned, the intended audience will be general public as well as decision makers and planning partners. We are also looking into ways to apply the tool in the planning and programming process, as we're planning webinars to demonstrate how this tool can be used by our planning partners as well as NPO board members during their training hours. And then in the long term, we expect that some performance measures will prove to be more useful than others. And also completely new databases may become available, so a revision of the 26 performance measures may be inevitable. And we will also continue maintaining it up to date in predetermined intervals, which will be likely every 2 or 4 years to go along with the short range and long range plan development. So there are 4 things that we would recommend anyone who is starting to develop a similar project. So the first thing, don't wait for the perfect time when all the data would be available and all resources would be in place. Rather work with what's available now, and later you can add into it. We also found that relationships with other agencies are extremely important when it comes to data sharing, data agreements, and basically overall trust that the data will be used for a good cause. When we started, we didn't know what we didn't know. So for example, we found out that smaller municipalities often don't even have in-house GIS. They may have some PDFs, some images, and that's how we realized that it's really important to have standardized data formats in the region. So things like this we identified as future opportunities for improvement. And then ultimately, it's important not to overcomplicate things, especially since our goal in the future updates is that those updates would be handled by NPO staff. So this is the end of our presentation. Thank you very much for the opportunity to talk about this. And Daniel, you can go ahead and take the floor.
All right. Thank you. So if we can expand the question and discussion pod real quick. We had a few questions that come up. The first one was from Caleb Winter, and it is, does ARC tip way projects that improve transit operations performance? If so, what method and data is applied? And it looks as though Seachin has provided a response. I wanted to open the line up to Seachin to see whether or not he wanted to expand on his response to Caleb's question.
Yeah, for the transit projects, we used to analyze separately. Like there are, because the transit projects, they have different types. They have expansion or upgrade, or the transit signal updates. So like the transit signal updates is usually a TSMO project, and we all analyze the emissions reduction caused by this project, and we think the score we give in the final ranking is emission is reduced.
Okay, thanks, Seachin. Caleb, if you got everything that you needed, if you didn't get everything that you needed, by all means, do a follow-up in the chat pod, and we will, elaborate as needed. The next question comes from Tejas at ARC. It's directed to UTEP. What is the quality of the active transportation data that you are using?
Yes, I think I can answer this. So basically, we ask agencies what data they have, right? So let's say for bikeways, it seems that the agencies are updating the bikeway network every year, so that was good. However, let's say for sidewalks, only one municipality had a data set of sidewalks, and they were not really 100% updated. Basically, they gave it to us with a disclaimer of that it may need some verification. Then let's say as far as walking and biking trips recorded by Strava, so we were able to get this data from Texas Department of Transportation, which they have, they're sending this data every quarter. However, since our planning area also covers 2 counties in New Mexico, on the New Mexican side, we didn't have any data from Strava. So it was quite challenging. Yeah, so I hope this answers your question.
Just to kind of piggyback on that question, and this is for ARC as well as UTEP, when we're talking about data and transitioning it from one source to the next in terms of the analyzing piece of it, when the data is transferred, is it just raw data that the tools will accept and go through some type of AI process to recognize the information so that you can easily analyze it? Or does it come raw and then you have to go through a process of cleaning it up before putting it into the tool? So we'll start with UTEP for a response and then go to ARC.
So at this first version, there was a lot of manual data cleaning that was handled by our students. But in the future, we would like to look into ways how to make it more automated.
Okay, thank you. How about the folks in ARC?
Hi, this is Shichen. I just want to take an example as like the INRIX data we currently use in our congestion management. They are, well, a big data. They have basically every 5 minutes performance on each VMT section, but actually when we use that, we usually use like the annual average data. So we do a lot of data cleaning by ourselves because sometimes in the planning works, our need and what the source data provided may not match.
Okay, thank you, Chishan. We also have a question from Kwa Ha Kim. If she's also from ERC, this is directed towards UTEP. She says that all performances are based on past/current data. How do you understand the future performances?
Yes, so at this moment, all the performance measures are based on historical data as they were, the latest data that was available. And we don't have any like a future prediction algorithms of what the performance would look like in the future.
This is Sonia Perez. For the tool uses existing historical data, but we do have our travel demand model, and we have not the same performance measures, but performance measures adopted by our transportation board that are generated from the model and are presented in our long-range plan. And there's similar some, but those performance measures are the ones that we use for future performance.
Okay, thank you. I do have a question, and I'm going to send this out to both ARC and UTEP. With technology changing so rapidly, how often do you anticipate, or have you updated the Dash tool as well as the web-based tool that UTEP is using? How often do you anticipate that you will need updating? And if you have practiced this already, what's the time frame in between updates? We'll start with ARC.
Hello, can you hear me?
Yes.
Oh, okay. So your question is how we updating this dash and all this with the data, other newly happening, right?
Yes.
Okay, so ARC constantly we monitoring and try to find a new data source again. I mean, I mentioned, data maybe too much, but literally, it's hard to find the right data set. So especially these days, it's a big data like INREX or NPM-RDS, or even we're talking about this micro level of mode information, which is pretty tedious, and signalization those data, and there's a bottom line is there's a huge flood to me, the data sources, and which is big data and new data, and in a ways, of course, better data source. Yet the problem is like how we're gonna putting together and bring that data to the manageable size or manageable understanding. So that's where we're spending quite a lot of time to talk about the data, quite a lot. So there's a state, Georgia State, and us, and CERTA, and ATL, our regions, the consortium, but we have a data management. We've been talking about quite a lot, and the data purchasing together. So we're talking about data. There's another huge effort. ARC is continuing work with other agency to bring this business intelligence business, basically. How are we gonna purchase the data right and maintenance and understanding through all this activity we're talking about. So to answer your question, there's endless work and there's huge new challenges for, I think, all of agencies, public agencies, how are we gonna managing it and how maintain it.
Okay. Thank you. Thank you very much. Let's get a response from the folks in Texas.
Yeah, so based on the conversations we were having with NPO staff about their needs, is that we will be updating this at least once every 2 years, so that it is aligned with their development of their short-range and long-range transportation plans, so that the data is always there updated before the development starts. Of course, ideal would be to, let's say, update it every year or even more often. However, based on how much time, effort it takes, it probably would not be feasible at this moment.
All right, thank you. We have another question in the chat pod from Axum of Choice. And the question is, how long did it take from notice to proceed to being able to generate a report? You mentioned future opportunities in terms of partnership data format consistencies, but in your experience exploring each performance measure, I'm thinking PM stands for performance measure, are there other opportunities you're seeing for automation? For example, automated API generation for new sources, testing data quality, and scoring, etc. We will start with ARC for a response.
Hey, this is Tejas. I can address some of this. So from getting in our project to having the final scores, that's a multi-month process. It took, I think, about 3 months in 2017 when we did it. It took 4 to 5 this past time. So it's a multi-month process to evaluate everything, to get all the data in and have some back and forth between us and our project sponsors to make sure that we have all the information we need from them. We are hoping to improve the data quality and data sourcing for future tip solicitations, and we want to iterate upon that process every time we do this, and even during the process improve it. That's a continual thing we are considering. In terms of getting things more automated, there are certain things we can automate more within our process in terms of pulling data reports from third-party sources and pushing them through a GIS tool as opposed to doing manual checks like we've done in the past for some variables. And all of these things are aspects we are considering and want to work on. I hope that answered at least some part of the question.
Can I add that answer too? I think we have to be, of course, as much as possible, automatizing all the method and the process. Yet, I think human kind of a touching is so crucial, because number is simply number, or any result can kind of fool us to somehow misleading. So I always want to understanding data through the automatization as possible, so all the efficiency and the effectiveness is the best. Yet every steps we have to check the quality of data, what is in, what is out. We have to know that, and you have to put those number as a human context, what we're really trying to do and how we understand all these stories. And with that, I think always the result is really more appreciated. Then so a lot of yes, automatization is very important process because these days data is huge. Even the modeling is just crazy, complicated. So without automatization, we're gonna drown ourselves to the truly couldn't breathe. But I think there's a lot of steps we have to must include our own kind of analysis and checking on the stories.
All right, thank you. Let's see. Let's check to see if there are any other questions in the chat. I do have one question for clarification, and I think it was during Taja's presentation where you had the 3 buckets in terms of ranking, scoring and ranking. Were you comparing TSMO projects to TSMO projects, or were you comparing TSMO versus other disciplines?
That's a great question. Yes, that is comparing TSMO projects to other TSMO projects. So within our TIP evaluation, we compare like projects to other like projects. So roadway expansion projects are compared to other roadway expansion projects, transit expansion to other transit expansion, and yes, TSMO projects to other TSMO projects.
Okay. Next question also is for ARC. The dash tool, was this created in-house?
Yes.
Yeah. All right. Let's see.
And in fact, Shi-Chen had a great skill with R, but before even Shi-Chen, we had a very separated the dashboard, the platform. So when we started RTP, project evaluation dashboard, that was kind of beginning of our dashboard, how we're going to communicate with the project geographically and each performance we can compare to. And we have, after that, we separately developed the TIP project dashboard. And finally, we could be able to stitch together all of the performances when Shi-Chen joined us to work with us. And to get there, actually, we really needed everybody. In other words, as I mentioned, the dashboard has to have a good looking and robust data and a meaningful performances. So going through discussion 360-degree of the firm planner and analyst and everybody, we had many talk round meetings. And to get there, again, if we have too much information, they're not using the dashboard because it's really confusing them. So go through this process preemptive ways is really make us much easier to connecting to people.
All right. Thank you. Let's check the chat pod again. The question. Just wanted to kind of get into UTEP and the El Paso NPO. You guys said that you're going to be rolling out the tool later on this month. Are we still on schedule for that?
This is Sonia from the Paso NPO. We still don't have a date that we need to present it to our transportation planning board first, and we're hoping is that this month, next month, we'll be presenting it, and then we can have the launch. So we don't have a date yet. We'll let you know when. We'll let you all know.
All right, thank you. I still don't see any other questions in the chat pod, so I'm going to go ahead and start closing this one out. I want to start by thanking all of the speakers from ARC, the NPO at El Paso, the University of Texas, El Paso. Thank you guys so much for taking time out of your busy schedule and working with us with this new normal to put on this webinar. Also want to thank Zach and the folks down at the Center of Excellence for partnering with Federal Highway, the Resource Center, to bring this to the discipline. And I wanted to also point to the useful links pod here that has some other information in terms of the newsletter and knowledge base center from the center, as well as webinar recordings that they have on YouTube and other sources. And we had a webinar centered around the same subject last week that was recorded as well. If you weren't able to join us then, by all means, go through the webinar recordings at the Center of Excellence, and you should be able to review it there. If we don't have any other questions, I'm going to go ahead and close this one out. And again, thank you all for participating.